Now before we start the next part, part C, what I'll do is I'll just remove that vector, okay, and remember in part B we found the general position vector of the boat B as it moved along here, T hours afternoon, and we called that B. So I'll just put that in one of the many positions along this line that B can be. Now in part C we're told that there's another boat C that starts at 12 noon and T hours after 12 o'clock its position vector C is given by this vector here. It's moving with constant velocity, we're told. Well, looking at this vector we can see that this part of the vector must be the velocity of C, and this part of the vector must be the initial position at 12 noon. So what I'm going to do is plot that on our sketch here. So minus 9i plus 20j will be from the origin 9 units to the left and 20 units up. So I'm going to assume that it's somewhere up here. It's not drawn to scale, but let's just imagine it's there. So at 12 noon then, let's just mark that in, 1200 hours, we have the boat at this point here, and we'll mark those coordinates in. That is at minus 9, 20. Alright, the boat C's there. And it's moving somewhere in the direction 6 units to the right here and lambda units in the J direction. And we're told that the boats intercept. And I'm going to assume that the boat is C is moving, say, somewhere in this direction. Let's just illustrate it in blue. Something like this, okay? Moving in that direction. Let's make it a dotted line, okay? So we'll just do that there, okay? And the boats intercept, so that would be that point there. And we've got to find out lambda. So how are we going to do this? Well, we know that at some time T hours afternoon, both this position vector and B are going to be pointing at this point, the point of interception. So that means that their I and J components will be exactly the same. So first of all, if I rearrange this vector C to put all the I components together, I will have 6t minus 9 in the I direction, so I'll put that in as 6t minus 9 in the I direction. And as for the j components, we will have 20 plus lambda t in the j direction, so that would be 20 plus lambda t in the j direction. And as I said earlier, at the point of interception, both this position vector of C, T hours afternoon, okay, that's going to be pointing actually up here. Alright, we'll just put that in there, okay. Both RC and B will be exactly the same vector, T hours afternoon. So that means then that I can just equate these components together. So if I compare the I components, let's just write that in, compare the I components, what I've got is 3 plus 2t must equal 6t minus 9. And with this equation, because there's only one variable in it, t, I can solve it for t. So if I add 9 to both sides and subtract 2t from both sides, I'm therefore going to have that 12 equals 4t. So dividing both sides by 4 is going to mean that t is equal to 3. So 3 hours afternoon the boats are going to intercept. And if you look at that sketch, you can see that that seems to make reasonable sense. Let's just show you. Look, you can see that if I move this velocity vector here, 1 hour it's here, boat B's here, 2 hours later it's there, 3 hours later both boats seem to intersect. Okay, so I'll just move that back to there. Okay, let's just carry on anyway. We've now got t equals 3 and our job was to find lambda, so all I've got to do now is just compare the j components. So we'll just come over here and just say compare the j components, and that means that we have got from the b vector 6t minus 4, 6t minus 4 must equal the j component over here, which is 20 plus lambda t, 20 plus lambda t. But we know that t is 3, so we can say that when t equals 3, alright, I'll come over here and just carry on. When t equals 3, we can substitute this into this equation. We have 6 3s are 18 minus the 4 leaves me with 14, so we therefore have 14 equals and 20 plus 3 lambda, so plus 3 lambda. Rearranging this by subtracting 20 from both sides leaves me with minus 6 equals 3 lambda. Dividing both sides by 3 leaves me with lambda equaling minus 2. And that's what we had to find, the value of lambda which allowed the boats to intercept. And that brings us now to the end of part C.